Well, it's 8 o'clock, time to start. We'll continue with the final exam review. The final exam on Newton opens at 3 p.m. on Monday. And make sure that you take the final exam practice on Newton. Okay, last time we were solving a quadratic equation, and we got to this stage where we're computing the square root of negative 48. So we can think of the square root of negative 48 as the square root of 48 times the square root of negative 1. And we're going to replace the square root of negative 1 with I, and we'll simplify the square root of 48. The largest factor of 48 that's a perfect square is 16. So we can write this as 4 plus and minus the square root of 16 times the square root of 3 times I, all divided by 2. Then the square root of 16 is 4. So 4 plus and minus 4 times the square root of 3 times I divided by 2. And then every term in the numerator and the denominator have a common factor of 2. So, or another way to put it, if we just divide everything in the numerator by 2, we get 2 plus and minus the square root of 3 times I. Those are the two solutions. Okay, the next one, number 2, find the distance between the points negative 7, 2, and negative 3, negative 5. So we all pick negative 7 and 2 to be the x2, y2, and the other point, x1, y1. So the distance is the square root of the quantity negative 7 minus negative 3 squared plus the quantity 2 minus negative 5 squared, the square root of that. And then we be careful with the arithmetic. So inside this set of parentheses, negative 7 minus negative 3, that's the same as negative 7 plus 3, quantity squared. And then inside the other set of parentheses, 2 minus negative 5, that's equivalent to 2 plus 5, quantity squared. And then a couple of more steps. Negative 7 plus 3 is negative 4. So inside the square root, we have the number negative 4 squared. And 2 plus 5 is 7, so we have 7 squared. The number negative 4 squared is 16. The number 7 squared is 49. So the square root of 16 plus 49. And finally, the square root of 65 is the distance between those 2 points. The square root of 65 cannot be simplified further. The next problem, solve the equation 5 times the binomial x minus 3 squared equals 85 using the square root property. So first we want to divide both sides by 5, and we get x minus 3 squared equals 17. And now we can apply the square root property. On the left-hand side, we get x minus 3. On the right-hand side, we get positive and negative square root of 17. The square root of 17 cannot be simplified further, so there's just one step left. Add 3 to both sides, we get x equals 3 plus and minus the square root of 17. Those are the two solutions. Okay, problem 4, solve the equation by completing the square. So step 1, we add 24 to both sides. So when we add 24 to both sides, we get negative 6x to the second plus 30x equals 24. Then we divide every term on both sides by -6. And doing that, we get x squared minus 5x. And on the right-hand side, 24 divided by -6 is -4. Okay, in this process of completing the square means that we're going to add a number to both sides of this equation so that the left-hand side is a perfect square trinomial. Okay, so now that the coefficient of x squared is 1, up here I'll write what we do. We're going to take 1/2 of -5. 1/2 of -5 is -5/2. And then we square that number. When we square the number -5/2, we get positive 25/4. Positive 25/4. So we add 25/4 to both sides of this equation. X squared minus 5x plus 25/4 on the left-hand side. On the right-hand side, -4 plus 25/4. The left-hand side is now a perfect square trinomial. We have to add the integer -4 to the fraction 25/4. So the least common denominator is 4. So in the next step, we'll write what binomial squared is equal to the perfect square trinomial. It's x minus 5/2 squared. And -4 is equivalent to -16/4. So -16/4 plus 25/4. And then we get x minus 5/2 squared equals 9/4. Okay, I ran out of room, so I'll continue this on an extra piece of paper. I'll just rewrite what we have here. The binomial x minus 5/2 squared equals 9/4. Now we apply the square root method, the square root property, to solve this. So applying the square root property, we get x minus 5/2 equals positive and negative square root of 9/4. And the square root of 9/4 simplifies to 3/2. So in the next step, we can write x equals 5/2 plus and minus 3/2. And we can simplify further. So one of the solutions is 5/2 minus 3/2, which is 2/2 or 1. So one of the solutions is positive 1. And the other solution, x equals 5/2 plus 3/2, which is 8/2, which simplifies to 4. So positive 1 and positive 4 are the two solutions. Okay, moving on then to the next problem. The short leg of a right triangle is 4 feet less than the hypotenuse, and the long leg is 2 feet longer than the short leg. Find the lengths of all three sides. Okay, I'm going to assign x feet to be the length of the short leg, x feet. And in this right triangle, the hypotenuse, this says the short leg of the right triangle is 4 feet less than the hypotenuse. So that's equivalent to saying that the hypotenuse is 4 feet more than the short leg. So the hypotenuse is x plus 4 feet. And then the long leg is 2 feet longer than the short leg. So since the short leg is x feet, the long leg is x plus 2 feet. Okay, so these are how we represent the length of 3 sides of a right triangle. So we're going to apply the Pythagorean theorem. We square the length of the hypotenuse, so x plus 4 squared. That's the length of the hypotenuse squared. And that's equal to the sum of the squares of the 2 legs. One leg is x, so when we square that, we get x squared. The other leg is x plus 2 feet, so we square that to get x plus 2 quantity squared. This equation is just a quadratic equation. So we'll multiply everything out, combine like terms. We'll set one side equal to 0 and then proceed to solve the equation from there. When we square x plus 4, we get x squared plus 8x plus 16. And that's equal to x squared. And then when we square x plus 2, we get x squared plus 4x plus 4. So I'll make the left-hand side 0 by subtracting x squared from both sides. The right-hand side has 2x squared, so when I subtract x squared from both sides, I'll just have 1x squared on the right-hand side. And then we'll subtract 8x from both sides. 4x minus 8x is minus 4x. And then we subtract 16. 4 minus 16 is negative 12. So we have 0 equals x squared minus 4x minus 12. And we can solve this quadratic equation by factoring. So x squared minus 4x minus 12, one factor is x minus 6, and the other factor is x plus 2. One of the solutions is positive 6. The other solution is negative 2. In the context of this problem, we exclude the negative solution. And so since x is 6 feet, then the short leg is 6 feet. So I'll go ahead and write it out. Short leg is x equals 6 feet or 6 feet. The long leg is 4 feet longer. So 6 plus 4 is 10 feet. Sorry, that's the long leg is 2 feet longer, so it's 8 feet. The hypotenuse is 4 feet longer. So you no doubt get the idea. Anyway, the hypotenuse is 6 plus 4 or 10 feet. So this long leg is supposed to be 8 feet. Okay, that worked out pretty nicely. So the next problem, a rock is catapulted. Its height above the ground, t seconds after launch, is h equals negative 16 t to the second plus 60 t feet. Find the number of seconds it takes for the rocket to be 32 feet above the ground. Okay, so h itself represents the height of the rock. So this should be the rock. So in this equation, replace h with 32. So we get 32 equals negative 16t to the second plus 60t. This is just a quadratic equation. So we'll make the right-hand side 0. We'll add 16t to the second to both sides and subtract 60t from both sides. And we get this standard equation of a quadratic. We can get rid of some of the clutter that's in the way if we divide every term on both sides by 4. We get 4t to the second minus 15t plus 8 equals 0. And then we'll use the quadratic formula. A is 4, B is negative 15, and C is 8. So t is the negative of negative 15 plus and minus the square root of the number negative 15 squared minus 4 times 4 times 8. And this is all divided by 8. 2 times 4 is 8. So we get t equals positive 15 plus and minus the square root of some number divided by 8. Negative 15 squared is 225. And we're subtracting 4 times 4 times 8. So we're subtracting 128. And then finally, t equals 15 plus and minus the square root of 97 divided by 8. Both of the solutions are positive. The smaller number, t equals 15 minus the square root of 97 over 8. Well, this is, the square root of 97 is close to 10. It's close to the square root of 100. So at approximately 5/8 of a second, less than a second after the rock is catapulted, it reaches a height of 32 feet. Then the other solution, 15 plus the square root of 97 divided by 8. So the square root of 97, again, is approximately 10. 15 plus 10 is 25. 25 divided by 8 is close to 3 seconds. So on the way down, the rock is at 32 feet at approximately 3 seconds. Okay, the next problem, number 7, solve the equation 3x squared minus 7x minus 2 equals 0. Okay, we'll use the quadratic formula. A is 3, B is negative 7, and C is negative 2. Okay, so x is the negative of negative 7 plus and minus the square root of the number negative 7 squared minus 4 times 3 times negative 2, all divided by 2 times 3. The negative of negative 7 is 7, and then plus and minus the square root of a number, all divided by 6, because 2 times 3 is 6. Inside the square root, the number negative 7 squared is 49. And we are subtracting 4 times 3 times negative 2. So we're subtracting negative 24. That's equivalent to adding 24. And then in the next step, x equals 7 plus and minus the square root of 73, all divided by 6. The square root of 73 cannot be simplified further. So those are the two solutions. In problem 8, write the standard equation of the circle x squared minus 7x plus y squared plus 9y equals 1/2. Find the center and radius. Okay, so we're going to add two numbers to both sides of that equation. One of the numbers will add to x squared minus 7x so that we get a perfect square trinomial. And then the second number, we're going to add that to y squared plus 9y to make that a perfect square trinomial. Okay, so we create space between the minus 7x term and the plus y squared term. And we also create space between the term 9y and the equals sign. In those spaces, we're going to add the numbers that complete the squares. So I'll rewrite this part. Okay, the number that we add to x squared minus 7x to get a perfect square trinomial, we take 1/2 of negative 7 and square it. So up here I'll write that 1/2 times negative 7 is negative 7/2. And then when we square negative 7/2, we get positive 49/4. So we're going to add 49/4 to both sides of the equation. And then we're going to complete the square on y squared plus 9y. So now we take 1/2 of 9, which is 9/2. So 1/2 of 9 is 9/2. And then when we square 9/2, we get 81/4. Okay, so we're going to add 81/4 to both sides. And why don't we go ahead and add these three fractions. The least common denominator is 4. So we convert 1/2 to 2/4. And we're going to get, let's see, 49 plus 81 is 130. And then add 2 to that, we get 132/4. Okay, so the standard equation, x squared minus 7x plus 49/4 is x minus 7/2 squared. And then plus y squared plus 9y plus 81/4. That's the same as squaring the binomial y plus 9/2. And the right-hand side is 132/4. This is the radius squared. Okay, so the center is the ordered pair positive 7/2 for x and negative 9/2 for y. And the radius is the square root of 132/4. And I'll leave that for you to simplify. That should be something you can do. Square root of 132/4. Okay, number 9, x squared minus 2x minus 15 is greater than 0. So we want to solve this inequality. We want to find the endpoints. So if we can find the factors of x squared minus 2x minus 15, since the right-hand side is 0, we can use the factors to identify the endpoints. One factor is x minus 5. The other factor is x plus 3. And the inequality greater than 0. Okay, so the endpoints are 5 and negative 3 are the endpoints. So we'll go through the process. Negative 3 is to the left of 5. Those two numbers divide the number line into three separate intervals. In the interval on the left, we can pick our test point to be -4. We can use either inequality, but the factored form for non-zero test points are usually more convenient. So in this inequality, replace every x with -4. -4 minus 5 is -9. -4 plus 3 is -1. And -9 times -1 is +9. 9 greater than 0 is true. So all of the numbers from -infinity up to -3 are solutions. In the middle interval, we can pick x to be 0. And then this time I'll use the original inequality. That we can use either one, but this one is when the test point is 0, this inequality is usually more convenient. Replace every x with 0, we're left with -15 is greater than 0, but that is false. So none of the numbers between -3 and 5 are solutions. Then in the third interval, we can pick x to be 6. And in the factored form, replace every x with 6. 6 minus 5 is 1. 6 plus 3 is 9. 1 times 9 is positive, and a positive number greater than 0 is true. So all of the numbers greater than 5 are solutions. The endpoints are excluded because the inequality doesn't have the or equal to part, so we exclude the endpoints. So we use parentheses at the endpoints instead of brackets. And then the interval notation is parenthesis -infinity, comma, -3 parenthesis, and then union parenthesis 5, comma, infinity. This is the interval notation. You should be prepared to write the algebraic notation, so I'll write what that is. If x is in this interval on the left, then x is less than -3. And then we write the word or. If x is in the other interval, then x is greater than 5. Okay, the next problem, number 10. Another inequality. This one is a rational inequality, and the right-hand side is 0. That's what we want. And the endpoints, the endpoint that comes from the numerator is -1, and the endpoint that comes from the denominator is +3. So we should be able to know by now, right at the outset, the endpoint 3 that comes from the denominator is not part of the solution, because if you replace every x with 0, then you're trying to divide by 0, but division by 0 is undefined. So we always exclude endpoints that come from denominators. And then endpoints that come from numerators, they may or may not be part of the solution. It all depends on the inequality. Since this is less than or equal to 0, that means we will include -1, which comes from the numerator. Okay, so we plot the numbers -1 and 3. 3 intervals to test again. So from -infinity to -1, let's pick -2. And then in the numerator, replace x with -2. -2 plus 1 is -1. In the denominator, -2 minus 3 is -5. -1 divided by -5 is +1/5, but the inequality is less than or equal to 0, and this is false. So none of the numbers from negative infinity to negative 1 are solutions. In the middle interval, I'll pick 0. Replace every x with 0. In the numerator, 0 plus 1 is 1. In the denominator, 0 minus 3 is negative 3. This is a negative number. A negative number less than or equal to 0 that's true. So the numbers between negative 1 and 3 are solutions. Then in the third interval, if we pick x to be 4, in the numerator, 4 plus 1 is 5. In the denominator, 4 minus 3 is 1. This is a positive number, but a positive number less than or equal to 0, that's false. So none of the numbers from 3 to infinity are solutions. Okay, we already noted that we're going to exclude the endpoint 3 because it comes from the denominator. And we include negative 1 because negative 1 gives us the inequality 0 less than or equal to 0, which is true. It's the or equal to 0 that makes it true. Okay, so this is the graph of the solution. The interval notation is bracket negative 1 comma 3 parenthesis. And the algebraic notation is negative 1 less than or equal to x, which is less than 3. Okay, and now we have a application problem. Bob and Cindy can trim the hedges in 3 hours when working together. Working alone, Bob takes 1 hour longer than Cindy. Find the amount of time it takes each to trim the hedges alone. Okay, this is a work problem, so equations have the form rate times time equals 1. When they work together, Bob works at a certain rate, Cindy works at a certain rate, and we're told that in 3 hours they can trim the hedges. 1 represents 1 job, which is trim the hedges. Working alone, Bob takes 1 hour longer than Cindy. So for Cindy, let's pick a variable for the amount of time she takes. So t hours for Cindy's time. So Cindy works at her rate for t hours to trim the hedges. And then Bob, his amount of time is 1 hour more than Cindy's, so Bob will take t plus 1 hours. So for Bob, his rate times t plus 1 equals 1. Okay, so what we want is an equation whose only variable is t. So we solve each of the equations for the rates. Bob's rate plus Cindy's rate is 1/3. They can trim 1/3 of the hedges per hour. Cindy's rate is 1 over t. Bob's rate is 1 over t plus 1. Okay, so we're going to, in this equation, we're going to replace Bob's rate with 1 over t plus 1. So 1 over t plus 1 plus Cindy's rate, which is 1 over t, and the sum of Bob's and Cindy's rate is 1/3. So we get this equation, 1 over t plus 1 plus 1 over t equals 1/3. The least common denominator is 3 times t plus 1 over 1. And then we multiply every term on both sides by the least common denominator. When we multiply it by the least common denominator by 1 over t plus 1, the t plus 1 factors cancel. So we're left with 3 times t. And then we add that to 1 over t times 3t times the binomial t plus 1. This time the t's cancel, so it's plus 3 times t plus 1. And then on the right-hand side, 1/3 times the least common denominator, 3 divided by 3, cancels, so we're left with t times t plus 1. Okay, so we just have a quadratic equation. So we'll multiply everything out, combine like terms. We'll set one side equal to 0 and then solve the equation. Okay, on the left-hand side, we get a total of 6t plus 3. The right-hand side is t squared plus t. So we'll make the left-hand side 0 by subtracting 6t from both sides and also subtracting 3. So 0 equals t to the second minus 5t minus 3. Well, we can't solve this by factoring. That is, t squared minus 5t minus 3 cannot be factored with integer coefficients. So we'll use the quadratic formula. If a is 1, b is -5, and c is -3. So we get t equals the negative of -5 plus and minus the square root of the number -5 squared minus 4 times 1 times -3, all divided by 2 times 1. And then we get t equals 5 plus and minus the square root of 25 minus 4 times 1 times -3. So this is 25 minus -12, which is 25 plus 12, or square root of 37. The square root of 37 is a number bigger than 5, so the solution we get by subtracting is negative. And we don't want that solution because t represents the amount of time it takes Cindy by herself. So our solution is, Cindy's time is 5 plus the square root of 37 divided by 2. So if you need to round this number to the nearest tenth, then you can use a calculator to find the square root of 37. But notice that the square root of 37 is close to 6. It's a little bit bigger than 6. And 5 plus 6 is 11. 11 divided by 2 is 5.5. So Cindy's time is approximately 5.5 hours. So Bob's time is about 6.5 hours because he takes 1 hour longer. Okay, moving on to the next problem, we have simplify 27 over 8 raised to the 2/3. So the denominator of the exponent is 3. So if you have an exponent that's a fraction, the denominator is a root of the number that you're trying to find. So we can think of this as 27 to the 1/3 raised to the second. Okay, so this works out pretty nicely, like they almost always do. The third root, or the cube root of 27 is 3, and the cube root of 8 is 2. If you want to write this in a little more detail, you can. If you apply this outer exponent 1/3, then we have 27 to the 1/3 divided by 8 to the 1/3. Okay, but the cube root of 27 is 3, so we're going to end up, I'll just put it in brackets again. The 27 to the 1/3 is the cube root of 27, which is 3. 8 to the 1/3 is the cube root of 8, which is 2. And then finally we square that quantity. When we square 3/2, that means 3/2 times 3/2, so we get 9/4 for the final answer on that one. Okay, the next problem, number 13, change the term 3x to the exponent 2/5 to an equivalent expression in radical notation. So remember, a radical has a radical notation, or a radical has an index. If you start out with something with a fraction as an exponent, the denominator of the exponent is the index of the radical. So if you want, you can rewrite this as the term 3x squared raised to the 1/5. And then if you raise something to the 1/5 and want to convert it to a radical, then it's the radical with index 5 of whatever it is, in this case, the term 3x squared. Okay, so this is an acceptable way to write the radical with index 5. But make sure that you understand what's going on. We're squaring the term 3x. So another acceptable way is to go ahead and square 3x. That means 3x times 3x. So the radicand can also be written as 9x squared. So either of those two is acceptable. If without parentheses you just write 3x squared, then that is incorrect. So make sure that you understand what's going on here. Okay, the next problem, number 14. Simplify the cube root of a quotient, 125x to the 15th over 27y to the 12th. Well, this works out really nicely. You can write this as a quotient of cube roots. So in the numerator, the cube root of 125x to the 15th. And in the denominator, the cube root of 27y to the 12th. And then in the numerator, the cube root of 125 is 5, because 5 cubed is 125. And the cube root of x to the 15th simplifies to x to the 5th, because the exponent 15 divided by the index 3 is 5. And then in the denominator, the cube root of 27 is 3. The cube root of y to the 12th is y to the 4th, because the exponent 12 divided by 3 is 4. Okay, the next problem, rationalize the denominator and simplify if necessary. So we have the square root of 64 over x to the 3rd. Well, this is not, for a number of reasons, this is not simplified, but among those is that we have a fraction inside of a radical. So we can write this as the square root of 64 over the square root of x to the 3rd. And then we can simplify the numerator. The square root of 64 is just 8. And there's more than one way to go about rationalizing the denominator. But at this stage, I'm just going to leave the denominator as the square root of x to the 3rd. So eventually we want an expression that does not have a square root in the denominator. So since the denominator has the square root of x to the third, remember we're going to multiply by 1 in a special form. So what we can do is the form that 1 takes is determined by what we're looking at in this denominator. Since it's the square root of something, we can ask, what would I have to multiply by x to the third to get a perfect square? Well, if I multiply x to the third times x, I get x to the fourth. And x to the fourth is a perfect square because the exponent is even. So if I use that reasoning, then I can multiply by 1 in the form the square root of x divided by the square root of x. So you'll agree that the square root of x divided by the square root of x equals 1, as long as x does not equal 0. But that's already a restricted value. So in the next step, in the numerator, we can write 8 times the square root of x. In the denominator, the square root of x to the third times the square root of x is the square root of x to the fourth. And then finally, we get our simplified expression. In the numerator, 8 times the square root of x. In the denominator, the square root of x to the fourth is x to the second, because the exponent 4 divided by the index 2 is 2. So now we have a rationalized denominator that doesn't have a square root in it. Okay, next problem, number 16. Simplify the cube root of 54y to the 14th. Okay, so we want to find factors of 54y to the 14th that are perfect cubes. The largest factor of 54 that's a perfect cube is 27. 27 times 2 is 54. The largest factor of y to the 14th that is a perfect cube is y to the 12th. Y to the 12th times y to the second is y to the 14th. So we can rewrite this as the cube root of 27 y to the 12th times the cube root of 2y to the second and then the cube root of 27 is 3, and the cube root of y to the 12th is y to the 4th, because dividing the exponent 12 by 3 is 4. And then the final answer, 3 times y to the 4th times the cube root of 2y to the second. That is the simplified answer. Okay, the next problem, number 17, simplify the square roots of the negative numbers. The square root of negative 81, we think of that as the square root of 81 times the square root of negative 1. Square root of 81 times the square root of negative 1. The square root of 81 simplifies to 9, and then we replace the square root of negative 1 with the letter I. So that's the answer to part A. In part B, the square root of negative 98. First, think of that as the square root of positive 98 times the square root of negative 1. We can simplify the square root of 98. The largest factor of 98 that's a perfect square is 49. 49 times 2 is 98. And then we'll replace the square root of negative 1 with I. So in this step, we'll write the square root of 49 times the square root of 2 times I. And then finally, the simplified answer, the square root of 49 is 7. 7 times the square root of 2 times I. Okay, we're about out of time for today. Tomorrow we'll look at more problems in our review for the final exam. That's all for today.